Hi everyone, Andre Adams here representing Team 5 for our fse100 instrument design proposal. What we're going to do is walk you through a little bit about our design and which 3 instruments we're going to be submitting, as well as presenting some of the evidence and calculations that helped bring us to that decision. So first of all, thanks for tuning in and being with us here. I'm going to go ahead and share my screen so that you guys can see some of the PowerPoint slides we put together for you. All right. Go ahead and put that into slideshow mode for you. So again, myself, Andre Adams, along with Annika and Travis, will be participating in this design proposal. One of the first things we need to do in any engineering task is to define the problem. So for us, that involves our band, Maroon Gold. Basically, the ultimate goal was to design something creative that would give them a solution for a wind, string, and percussion instrument. A lot of requirements that came along with that, such as size was a big issue. All 3 instruments, 4 in some cases, had to fit inside of a 2 cubic foot stage box. So we definitely have to get creative to make these functional yet compact enough to be able to carry along. Cost, each instrument had to be less than $15. And of course, it has to be functional and aesthetic. So, if it doesn't do the job they need it to do, it wouldn't be very useful for them. So, in a nutshell, the main 3 items we tried to focus on are be creative and unique, make it small enough, and of course, make it work. So that brings us into the proposed design. I'll tell you a little bit about the percussion jam block that we chose first off. So here's a look at 3D model in a technical CAD drawing. The goal for this one was to make it a medium pitch frequency. So we did a little background work on some of the common instrument designs that are out there, and how can we engineer something that will be an adequate solution for this band. So what I chose to do on this particular unit is, given the design constraints and the cost constraints, I chose to go with a PLA plastic, and we had 2 options basically. I could machine this and make it functional, try to make it aesthetically pleasing, or we can use technology. Since we have the 3D model, we can go ahead and get it 3D printed using the stereolithography techniques. So here's a little background on the PLA plastic, which is the most economical choice, and some of the characteristics of it. It's very similar to ABS. There's a lot of information out there. And total, with shipping and then myself doing some of the sanding and coloring, our 3D part can come in just under $15, just under the budget. So we're in good shape there. Here's a little bit on the modes and fundamental frequencies. We tried to illustrate these in the form of a graph. So along the x-axis, of course, you're going to see the mode number and then the frequencies in hertz. So we tried, again, to focus on designing something that would yield a medium pitch. So just to give you some examples, if you look at the numbers here, this is going beyond just the mode numbers. If we were to alter the length of the part, for instance, if you took half the length, it's going to create a higher pitch sound, right? If we double the length, it's going to be a lower pitch. So we try to get somewhere in between there, which gives us roughly a 4-inch long part. It's cantilevered rather than simply supported. So these are the estimations on the frequency for the medium pitch percussion jam block. That brings us into the proposed design for the string instrument, which I will pass this off to our next team member to explain a little bit further as we continue to validate some of the decisions we made here. All right, so as I said, I'll pass this off to our next team member, and thanks for joining us. Stay tuned.